In the blue-orange dye solution experiment, we have a mixture which is composed of a blue dye and an orange dye, and our job is to determine the concentration of the blue dye and the concentration of the orange dye in this mixed solution. We will be using absorbance spectroscopy and a spectrometer very similar to what we did with the riboflavin experiment, but this time we have a mixture as opposed to just one component as we did with the riboflavin experiment where we just were analyzing riboflavin. Now we're analyzing both the orange component and the blue component. We can do that with spectroscopy because where these two materials, the orange dye, the blue dye, absorb light, where their analytical wavelength is quite different. For example, in the orange dye spectrum, we see that its analytical wavelength is around 460 or so nanometers. Apparently 464 is where the peak is. And at around 600, the absorbance is essentially zero. If we look at the blue dye absorbance spectrum, we see that it peaks between 600 and 650. It peaks at 629 nanometers. And around the 464 nanometer range, there's very little absorbance, if any at all. So what we do is we set the spectrometer to around 464 nanometers when we're working with the orange dye component of our mixture, and we determine the absorbance of our unknown dye, and from that we determine its concentration. Then we set the spectrometer to around 629 nanometers. We determine the absorbance for the blue dye component of our mixture there, the unknown. We go from absorbance to concentration, and then we have the concentration of the blue part. A difference between this experiment and the riboflavin experiment is we are given the absorbance spectra. We don't have to measure them. That's what's shown in figures 1 and 2. We are told what the analytical wavelengths are. We're not having to determine those. What is similar about this experiment is we will have the stock solutions. We will have an orange stock solution with a stock concentration. We will have a blue dye solution, a blue dye stock solution with a stock concentration. Those will be given to us. I will give them to you in the experiment video, so we will have their initial concentrations. We will, with the orange dye, make some dilutions, determine the absorbances of those dilutions, make a calibration graph, and then determine the absorbance for the orange component. And from the absorbance value, from the linear fit to the orange data, the calibration graph, the calibration equation, we will be able to determine the concentration of the orange dye component, and we will do the same for the blue at its absorbance, at its analytical wavelength. So we will be doing the dilutions for both orange and blue part components and creating a calibration graph for each part. And that's what's described in the overview. It's also described that we are using not that same large spectrometer that we used with the riboflavin. We're using a small one that hooks up to a LabQuest, and it has 4 wavelengths we can choose to work at. The closest wavelengths to what we need are 430 to probe the orange dye component and 635 nanometers to probe the blue dye component. Alrighty, so we're told to prepare the dilutions, and those are prepared following this table here, where in test tube 1 we have 2 mLs of the stock solution, and we add 8 mLs to that to get a total volume of 10 mLs. Test tube 2, we had 4 mLs stock solution, 6 mLs water. Test tube 3, 6 mLs stock solution, 4 mLs of water. Test tube 4, 8 mLs of stock solution and 2 mLs of water. And then in test tube 5, that's just straight stock solution. So its concentration is whatever the concentration is that is on the bottle of stock solution. So we will do test tubes 1 through 5, prepare those for the orange dye component stock solution and for the blue dye stock solution. Those concentrations, by the way, are good to 2 decimals, so 2.00 mLs, all the way to 10.00 mLs. And we then are told to go to the results table, which is way down here. And for the blue dye, for the orange dye, we are told to basically copy those volumes that are in that table, so the 2, 4, 6, 8, 10, and the amount of water added. And then we are told to calculate the concentration of the final solution. We will need that because as soon as we collect the absorbance data for those 5 dilutions, we will go to a computer and use Logger Pro and generate the calibration graph. Well, the calibration graph is absorbance on the y-axis versus concentration on the x-axis. So we will have to have those concentrations. So the concentration of the final solution we get from the dilution equation. The dilution equation is M1 V1 equals M2 V2. M1 is the molarity of the stock solution. V1 is the volume of stock used. V2 is the volume of the total volume, which will be for all of our test tubes 10 mLs, 10.00 mLs. And M2 then is the concentration of the final solution. So go ahead and prepare that for both the blue dye and the orange dye, so you have all those concentrations. Alrighty, now going back to our procedure where we left off. So we are told to prepare those dilutions, which will be shown to you in the experiment video, and then we are setting up our LabQuest. The mode is events with an entry, so the one that the spectrometer takes, that's the absorbance. We enter then the concentration, which is why we need that for the we need the concentrations early on. Our unit is molarity for concentration. Alrighty, and then we're told to set, first off to zero the spectrometer, kind of like we had to zero the spectrometer used with the riboflavin experiment. So we zero it, and then we determine the absorbance of test tube 1, of test tube 2, all the way up through test tube 5. And then we have our unknown in test tube 6, and after we have come out of the mode, we just simply determine the absorbance of test tube 6 for each of the blue dye and then the orange dye. And then we take this data and we go to a computer, get into Logger Pro, transfer the data, and we should get a graph of absorbance on the y-axis, concentration on the x-axis. We will give it a title You could call it absorbance versus concentration. Do indicate whether it's the orange dye or the blue dye data that you are talking about, because you will have two graphs total. Both of them are calibration graphs, absorbance versus concentration, but one is for the orange dye, one is for the blue dye. And we're also told to convert to scientific notation because our concentrations are very little and they will otherwise look kind of like zero, but they really are just not zero, but a small number. We will do the linear fit because we see that our data is linear, and we will then get a slope and a y-intercept and a correlation coefficient. All of that information will be on the graphs, the two graphs that I will make available in Canvas. So as usual, you can skip the pre-lab, and then coming to our report. So we talked about already the first part of the experimental data. All the absorbances, those are of course what we measured with the spectrometer and LabQuest for both the orange dye and the blue dye. And over here in the calculations and results, we will put the slope from our graph, from our calibration graphs. That will be, we will have that for the blue dye, and we will also have a similar bunch of information like this for the orange dye. So the slope, the y-intercept, the correlation coefficient, which hopefully is close to 1, very close. And then using our slope and our y-intercept, we write the equation for the best fit line from the calibration curve. So the equation should be A, absorbance, equals slope, this slope here, the number, times C for concentration plus the y-intercept that is here. And then using the absorbance of our unknown in the blue part of it, given the analytical wavelength we were working at, we use that equation from question 1 here to give the concentration. Then we do the same thing for the orange dye part. So now at this point we will have concentrations for both components, and then there's a few questions. And when you're done with that, make sure that you are happy with your results and scan it, prepare it as a PDF file, and submit it.